Myself, Dr. Maheshwara Rao, Department of Civil Engineering, Institute of Aeronautical Engineering. So our course name is Fluid Mechanics, and the topic name is Fluid Pressure at a Point. So what is meaning of the fluid pressure? Here is the point is there, pressure. Fluid pressure means the pressure applied by the fluid, which is called here fluid pressure. At a point, that means at any point in the fluid, inside the fluid, so pressure will be exerted by means of the fluid. Okay. So why should we learn this fluid pressure? So if you want to design a submarine, so the submarine will travel inside the water, inside the ocean, at a certain depth from the top surface. See, if you go deeper and deeper into the ocean, what will happen? If you take a point at a deeper point of the fluid, so whatever the height of the water above that point, that will exert a pressure onto that particular point. That means if you go deeper and deeper, the pressure, applied pressure will be more. It will be increased as you go inside deeper and deeper into the fluid. So here fluid pressure will be zero at the top surface because there is no fluid above the top surface of the fluid. So if you go inside the fluid, so as you increase the depth of that point, particular point inside the fluid, it is also directly proportional to the pressure. So pressure will increase as depth increases. So that we will deal with the topic. So before going to the this topic, the course outcomes of this are, that means the student will be able to do some certain things after completion of this course. So those are called course outcomes. The course outcome one is fluid properties. Here the students will learn what are the different fluid properties, surface tension, all those things. So that will come under the course outcome 1. And course outcome 2, it related to the Newton's law of viscosity. So fluids are majorly divided into 2 types. There is a Newtonian fluid, non-Newtonian fluid. So which obeys the Newton's law of viscosity, they are called Newtonian fluids. Which will not obey the Newton's law of viscosity, they are called non-Newtonian fluids. So according to this, so the students will learn Newton's law of viscosity and the classification of fluids based on this Newton's law of viscosity, and also some problems they will solve on the viscosity, which is the course outcome 2. So, and capillary rise and capillary fall. That means a small given tube, small tube, that means small diameter tube, if you insert into any fluid, okay, so the fluid will rise in that particular smaller diameter tube compared to the top surface of the fluid, or sometimes the level will fall inside the small tube compared to the top surface of the fluid. So which is called a capillary rise if it is rising, and it is also called capillary fall if it is falling in a smaller tube, diameter of the tube. So that capillary rise and fall knowledge will come as per this course outcome 3. Then course outcome 4 is that surface tension and their applications. So surface tension means the name itself is having any fluid at the top surface of that fluid, it will have tension. So much tension is there, what direction the tension is there. Those details will come in the course outcome 4. Course outcome 5. So capillarity and compressibility. So capillarity means it is a rise or fall. Compressibility means change in volume of that particular fluid. So some fluids will change more. Example, gases, if you compress it, volume change will be more. And whereas water, it is incompressible, volume change will not be there. So that is called a compressibility. And the density also varying. If more compressible, density also vary. If incompressible fluids like water, the density is a constant. So those concepts will come in the, it is treated as this course outcome 5. So course outcome 6 related to this pipe flow or fluid friction. That means whenever a fluid is flowing inside the pipe, so because of the surface and fluid surface and material surface, pipe material surface, there will be friction because of the flowing of the fluid, so which is called fluid friction. So due to this friction, the energy will be lost if it is travels for a certain distance in a pipe. So those pipe flows is here course outcome 6. So now today's topic is introduction to fluid pressure. So I already told you fluid pressure is the pressure applied by the fluid into a fluid or onto any material which is present inside the fluid. So that is called a fluid pressure. See here you can see the definition. So it is a normal force exerted by a fluid per unit area at a specific point. This is point should be there within the fluid or on surface in contact. That means so if fluid is there, if you take some point here. So here, this is the fluid pressure will be exerted. This much height of the water, weight of this water will be acted on this point. So here, if no material is there, then the fluid will exert itself on the fluid. So which is a pressure within the fluid, or some object is there like any submarine like that. So here also pressure will be exerted at certain point if the material is present. So the surface of contact with the fluid or fluid within itself also will exert pressure. So that is a fluid pressure. So here you can see the name scalar. So the quantities are measured majorly in two types: scalar quantity, vector quantity. So what is the difference between scalar and vector? The vector is having some force with a particular direction. So whereas scalar is a quantity which is not having any specific direction. So only magnitude of that force will be represented and without representing the specific direction of that particular force. So which is called a scalar quantity. See here, fluid at rest. So what is the meaning of fluid rest? If the fluid is not moving, it is stagnant, then it is called a fluid is at rest. So pressure is exerted equally in all directions, which is called a Pascal's law. That means if a fluid is there, so if you take a point, if this water is not moving, then here in all directions, the fluid, the pressure will be same in all directions, which is called a Pascal's law. So that is, condition is that the fluid is static. That means fluid is not moving, that is fluid is at rest condition. If you see the units, so what we told the pressure is nothing but the force per unit area. So force is here newtons, area means here meter square. So here the word is there Pascal. So pressure is measured in terms of SI units. If you see the SI units, the pressure is measured in terms of Pascals. What is the meaning of Pascal? It is a Newton per meter square. Newton per meter square. And the symbol is given here, capital P suffix A. So 1 Pascal is equal to 1 Newton per meter square. So other units commonly used to include are bar. The same pressure is also measured in terms of other units, that is called a bar. Bar is also a unit for the pressure or atmospheric pressure, pounds per square inch. So here pounds per square inch or bar or Pascal or these are the different types of units we can use to fluid pressure. So if you see the mathematical expression for this pressure, it is nothing but the P is equal to F by A. So the pressure at any point in a fluid which is equal to F by A. So where P is called the pressure in terms of pascals, F is the normal force exerted by the fluid. The force will be exerted by the fluid. So onto the fluid or onto the object. So then A is equal to area on which the force is exerted. So on which area it is exerted. So if you see the figure, you can observe here it is moving a straight line. Here it is moving curved line. Here it is moving somewhat lower line. So why it is means here is high pressure is there. Here is somewhat lower pressure is there. Okay. Then here it is very less pressure is there. Here is more pressure is there. So why means it is because of the weight of the fluid. So if you take this point, okay, so the height of the fluid is more here. Then it is having more pressure. If you take this height is less compared to the top surface of the fluid. Okay, so then lesser height, that's why pressure is less. Here, still more, it is a very small height. So that's why the pressure is very less here. We can observe with this figure also. If the 4 meters any object is there, or 7 meters object is there, the 7 meter depth and depth of more depth, then it will have more pressure. The same material will have different pressures. So fluid will exert a pressure onto this any material or equipment inside the water. The pressure will be less at lesser depth and pressure will be more at higher depth or deeper one. So here you can see here static. So what is static? I already told you the fluid will have in two conditions. One is static, that means without moving. So example, if you take a lake, so the lake water will not move, will not go anywhere. Okay, so if it is a lake, okay, so then the water will not move. That is called a static. So dynamic or kinetic, that means whenever the water is flowing, like a river. So when water is flowing near a river, which is not static here. Okay, so here fluid pressure in the static fluid. So what is telling here is the fluid at rest. So first point is fluid at rest. Pressure increases with the depth. That means if depth is increasing, pressure is increasing. So why it is increasing? Because the weight of the water, the weight of the fluid above that point. So not only here water, even air. So earth is having some atmosphere which is called air. So if it is here, it will have some atmosphere pressure. If you go higher and higher, it is different. Lower pressure will be there at the highest points, like Mount Everest or Himalayas, whatever it may be. If you go higher and higher, what will happen? The height of this weight of this air at this point is more. Weight of this pressure at this point is less because weight of the air column at the top surface of that above that point is less. That's why lower pressure. So then normally what will happen if anybody is climbing the Everest? Okay, so Everest hill is there. So somebody is climbing this. So what will happen if you go on the higher and higher points? So what will happen? The height of that air column will be reduced compared to bottom. So here this is the height of air column. Here it is height of air column. What will happen here? At the bottom it will have atmosphere pressure. That's why we are staying safely. But here it will be less than the atmosphere pressure. That's why outside pressure is becoming less, so that the fluids in our body will come out. So whatever it may be, it will come out through the nose, ears, eyes, like that. So why it means inside pressure is higher in the human body, and outside pressure is less as you go at higher altitudes, like this at highest hill. Okay, so that is the static fluid statics. Okay, here hydrostatic pressure at a depth h in a fluid density rho. See here different things are there. Hydrostatic pressure means it is a fluid at rest. So without moving, the fluid which is not moving, it exerts some pressure which is called hydrostatic pressure. So depth h is the depth, that means the top surface of the fluid to certain depth. So this is the top surface. Then at a particular point, This is called depth. So top surface of fluid to any particular point. And rho is the density. Here is rho is the density. So weight by volume. Density means weight by volume. So that means if you take 1 cubic meter of fluid, how much it weighs. So 1 cubic meter of air, how much it weighs. 1 cubic meter of water, how much it weighs. 1 cubic meter of mercury, how much it weighs. So that is called a density. And gravity. Gravity is a small g. So formula is here. Static pressure is equal to P is equal to P naught plus rho gh, where P naught is the atmospheric pressure plus this rho gh. Rho is the density of the fluid, g is the acceleration due to gravity, and h is the height of the fluid or depth of the particular point below the fluid. So in this, P is equal to P naught plus rho gh. So P naught is the pressure at the fluid surface, usually atmospheric pressure. So that is the top surface of the lake or top surface of the river, whatever it may be. But it should be rest, not river. Okay, rho is the density kg per cubic meter. So g is equal to acceleration due to gravity, 9.81 you can take, and h is the depth below the fluid surface. So here two types of pressures are there. You can see here absolute pressure and gauge pressure. So what is the meaning of absolute pressure? In other words, total pressure. Absolute pressure means total pressure, which includes the atmospheric pressure. Okay. So absolute pressure is equal to gauge pressure plus atmospheric pressure. So both atmospheric and gauge pressure. So whereas gauge pressure is, if you take mathematics, then P gauge is equal to P absolute minus P atmospheric. So this formula is coming from this only. So gauge pressure is nothing but the P absolute pressure minus the atmospheric pressure. So you can see this, the fluid will exert pressure onto the surface of the material, which is inside this is the fluid, inside the fluid. Whatever it may be the object, it may be ship or it may be submarine, whatever it may be, the fluid will exert pressure on it. So to design the submarines or the ships, so this pressure, fluid pressure, we have to know it. That is the practical application. And you can see the fluid pressure. So if the equipment or any pipe which is not designed as per the existing pressure, so what will happen? Then here like this, cracks will come. So the fluid will come out. So failure of the pipe will occur, failure of submarine or failure of ship, whatever it may be, if it is not designed properly based on the fluid pressure, then the failure will occur like this. This is a photo of which is having crack, got fracture, okay, damaged due to the pressure of fluids, so that the fluid will come out. So if you see, so today what we learned, so introduction to fluid pressure is nothing but the force exerted by the fluid per unit area within the fluid or onto the surface of contact, which is a scalar quantity. That means it is not having any specific direction, only magnitude is having. And fluid is at rest, that means it's static. Okay, so pressure will occur in equal all directions, which is called Pascal's law. Then units for this fluid pressure is Pascals, Newton per mm square, meter square is called Pascal. And it can also be used, bar is usually for the fluid pressure. It is another unit, atmospheric pressure, and pounds per square inch is also unit for the fluid pressure. So the formula for the fluid pressure, P is pressure, P is equal to pressure, F is equal to force, A is equal to area over which the force is exerted. So as you go, height of this water, weight of water. So okay, this more height, more pressure, less height, less pressure. So 4 meters will have less pressure, 7 meters will have more pressure because the depth is more. And static here. So static pressure is the pressure increases depth due to weight of the fluid above that point. So above that, point. So if you go deeper and deeper, the height of that water or depth of water is more. That means weight of water above that point is more. Hence pressure will be increased. So here the formula here P is equal to P naught plus rho GH. So where P naught is equal to pressure at the surface. That means the surface, this is water, this is the surface. So what is the pressure here? Gauge pressure is 0, but here will be atmosphere pressure will be there. That's why P naught is equal to pressure at the fluid surface, which is also called fluid atmosphere pressure. So rho is the density of fluid, is the acceleration due to gravity 9.81 meter per second square, is equal to depth of fluid from the below the surface. So total pressure, two types of pressures are there, absolute pressure and gauge pressure. Absolute pressure means total pressure, which includes the atmosphere pressure. So P, absolute pressure is equal to gauge pressure plus atmosphere pressure, and gauge pressure is equal to absolute pressure minus atmosphere pressure. So practical application, you can see the submarine design, ships design. So whatever the machinery traveling inside the water, okay, you have to apply this pressure. Okay, so before knowing the pressure, the fluid, we cannot design the ships and submarines, all those things. So if you don't design properly, then failure of that particular thing will happen. So example, this breakage of this pipeline. So if more pressure is inside, then it will blast. That means crack will occur, damage of the pipe will occur, and damage of ship or anything will happen if you are not properly designed based on the fluid pressure. So references are K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw Hill 2012, and Modi AP and Hassan Seth, Hydraulics and Fluid Mechanics, Stanford for student. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.